card. Okay. Require some kind of external validation, confirmation. Yeah. Happy Thanksgiving, Jimmy. And I'm sure the Americans in the audience are like, what? Thanksgiving? Now? October 13th? Yeah. Canadian Thanksgiving is about a month and a half earlier than American Thanksgiving. And every time Canadian Thanksgiving comes around, I remind Americans that it's a much better idea to have your Thanksgiving, your celebration of the harvest, and family and friendship in early October instead of late November, because the weather is better. And so you don't go through all of that travel nightmare, driving along snowy roads, getting caught up in winter storms, trying to go and visit your family. Everything is fine and it's easy to get around. And so I highly recommend Americans, you shift your Thanksgiving to the same one that we have in Canada. All right, so let me make sure that this is set up properly. And that, and there you go, Chad. So there we go. Got the screen that's going to be the color for the episode, and there's the grayscale one. Okay, and I am recording. And Zapfan's here in the afternoon. How do you like that, Zapfan? This is just for you, not for everybody else. Okay, so if you're wondering what it is that you have stumbled into, this is going to be my live question show where you ask me your questions about space and or astronomy or whatever. If you want to trigger a rant, you just need to use the right code words to unlock my ranty behavior. So for the next 2 hours, we will explore all things space and astronomy, guided by your curiosity and my knowledge, I guess. But a few ground rules. So the first thing is, go ahead and put any questions that you have into the YouTube comments. Zapfan is here. We'll grab those questions, throw them into the database, and then I will be able to look through those questions and be able to answer them. And it's a good thing because it looks like the plugin is still failing, so we don't have our backup, our AI backup. So I'll have to sort that out once and for all. So go ahead, put any questions. Just put your question in once. So once, it's in the database, we got it. And then I will review it and consider it. And if you put it a bunch of times, it's just going to get ignored. So once you ask it, ask a different question. And then maybe we'll get a chance to get to all of them. Now, keep in mind that I am a journalist, not a scientist. And so I can only sort of provide what is considered the scientific consensus on matters. I am not able to give you an opinion about scientific matters. And, I think that for a lot of people that sounds confusing. And that is just that I think it's really important to recognize the expertise of the people who have put in the time and effort and energy and work to learn this stuff and make progress in science in the first place. That if you want to go that route, then and sort of put in the amount of education that's required to be able to have an opinion about this kind of stuff, that's very powerful. And I deeply respect it. But I think if you haven't put in the time, like I haven't, then you have to acknowledge that as a limitation and adjust your perspective. And that the trap that we have when we have limited information, limited knowledge, limited understanding, limited expertise is to say, why don't they just? right? Why don't they just, and then apply that to whatever scientific endeavor? And the reality, of course, is that they thought of that. That you know, the reason they didn't just is there's a very good reason why they didn't just. And so instead they're having to be confused, having to be have, you know, conflict, having to be skeptical, having to have continued debate and argument and discussion, develop new tools, because the answer is not as cut and dry. And your assumption should be that there's a reason why the answer is not so cut and dry. And to postulate an opinion when you have not put in the level to understand the true landscape is, you know, is not the wise move. So that's why I sort of repeat that. And I hope that sort of lesson sticks with all of us as you go out there in the world and you start to see things as an amateur and have an opinion and go, wait a minute, why don't they just, you know, X? Well, because it's hard, it's complicated, it requires a lot of time and effort and energy. And you think about the things that you do in your daily life, the things that you're an expert at, the things that you're really, really good at. And you think about the time when somebody comes up and looks over your shoulder who has no experience in this and goes, why don't you just blah? And you're like, well, it's very complicated, right? Here's why I can't just replace the transmission on this car. Here's why I can't just fix this faulty code. Here's why I can't just land this plane in a hailstorm. There are reasons. It's complicated, and so you have to. Here's why I can't just speed run this level of the video game. Here's why I can't just navigate my way through the social dynamics of being a teenager. These things are complicated and require experience and training, and then you can get to a place where you know what you're talking about. But anyway, that was a mini rant. So the second thing is that I try to give emphasis to the people who have never had their question answered before. And Zapvan is here, is going to be able to grab your questions, put them into the database. I will be able to evaluate them, and I will see the number of times that we have already featured you in our show. And so I will try to look for the people who have never had their question featured in any of our question shows and just focus like a laser beam on what you've done. Now, that said, I do run a kind of running commentary in my brain of the episodes that we've done in the past. And so if it feels like it's the same question we get every week, that could be in the FAQ, 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 is it pronounced FAQ? I think it's FAQ. In the FAQ, then I may skip your question, or I just don't know the answer. I'm sort of deferring back to number one, which is I'm not going to try to give you an answer when I am fairly certain that I don't know. And I'm not going to hallucinate on the spot for you like a large language model. I am going to respect the uncertainty. And I may just tell you I don't know the answer to this question. Great question. I have no idea. Moving on is you may hear this a lot. All right, that was the sort of intro. So let's get cracking on the questions. Oh, looks like the AI is working. Hooray for everything. Okay. Jimmy James, what vegetarian food do you eat for Thanksgiving? I tried toadurkey once, and it was damn good. So people may or may not know I'm vegan, and so, you know, that requires, you know, it definitely changes things. And so the ritual that my wife and I have gotten into is that we turn every holiday, Thanksgiving and Christmas mainly, into some kind of dessert-related feast. And so we call it Cakesgiving and Cakesmas. And so for Cakesgiving, I will usually make a couple of chocolate cakes and maybe an apple pie, and then that will be dinner. Is that we will just like skip all of that nonsense and just get straight to the part that we all want, which is the dessert. And I don't make cakes, pies at any other time of the year, but I will make that for Thanksgiving. And then we'll do the same thing for Christmas. So we will make, you know, a bunch of desserts. And sometimes I'll just make like a whole bunch of like cookies, or I will make just like super unhealthy food. And then we just gorge on that, and then we call it a day, and then we don't feel the need to eat junk food like that in the house any other time. So yeah, so I've got great cake recipes. I can make an apple pie, all that kind of stuff. So that's what I tend. I've made lemon tarts, all kinds of good stuff. So that's our routine, to kind of just skip the whole thing. And so then for the family, I will deliver cakes to people. We don't typically get together as for a big Thanksgiving dinner, just in my family. Just we're all sort of broken up all over the place. And so typically I'll sort of make the rounds and spend time with everybody. But yeah, that's what we do. And then my sister is First Nations and so they celebrate no Thanksgiving, which I think is awesome. SSA Laura. Our moon is tidally locked and moving away from us. Will it remain tidally locked forever? What happens if it gets too far away from Earth? Will it fly off into space? So the moon is tidally locked to the Earth, and the Earth is not tidally locked to the moon. So the Earth is turning the moon takes about 28 days to complete one orbit around the Earth, and it takes about 28 days to complete one turn on its axis. And so from our perspective on the surface of the Earth, we see the same side of the moon throughout its entire orbit, and always have, and always will. But we are still rotating, and that this early on in the history of the Earth and the moon, this wasn't the case, that the moon was turning, the Earth was turning, but tidal forces always inexorably push towards this process where things lock together. Now the moon the moon has less mass, it is smaller, and so it was able to lock to the Earth first. But this process is still continuing with the Earth, which is that the moon is trying to lock the Earth to the moon and slow down the Earth's rotation. And then as a result, for conservation of momentum, this causes the moon to drift away by about a centimeter a year. And so what you end up with, I always get this wrong, right, Chad? The moon is moving away by 2.5 centimeters a year. All right. It's one or the other. The moon is moving away by 2.5 centimeters a year. And so what you get is that the Earth's day rate gets longer, the moon gets farther, and eventually the Earth and the moon will lock to each other. The Earth will only show the same face to the moon. The moon will only show the same face to the Earth. The moon will stop drifting farther away from us. And that will happen in about 50 billion years. So long after the sun has died, probably consumed the inner planets, maybe even the Earth. And so it's kind of a moot point. What will happen when the Earth locks to the moon? The Earth and the moon will have been destroyed by the sun in some way, by it turning into a red giant. Or not. But but that process will continue on. Ugar E. Okay, I'm going to ask... Ugar E. What can we do against a rogue planet that is on a collision route to Earth? Nothing, right? If we determine that there is a rogue planet moving through the solar system from, an interstellar planet, like a giant comet through our atlas, and it is on a collision course with the Earth, there is absolutely nothing that we can do. The mass involved with an object like that is just enormous. It's the mass of the Earth, probably, right? Or more than the mass of the Earth. And we don't have any way to change its orbit under the sort of current capabilities. And so what do? We just get hit. Maybe we move some people off to the moon. Maybe we move some people off to Mars. But if this object is passing through the solar system, it is going to gravitationally perturb all of the planets. It's going to cause mayhem. And, one of the things when you look at the orbits of the planets and how they are, although not perfectly circular, they are, roughly circular. It tells us that a giant rogue planet probably didn't pass through the heart of the solar system any time in the solar system's 4.5 billion years. That these are very rare events if they do happen. Stars get close, but not that close. Black holes probably got close, but not that close. And rogue planets probably get close, but they don't go right through the heart of but they haven't gone right through the heart of the solar system. And so, what are the chances that this is going to happen in the future? Not zero, but really close to zero. And so it's the kind of thing that you shouldn't worry about. Tim Armstrong, are there any other interstellar objects that we are currently tracking other than 3I Atlas? No, not right now. Oumuamua and Borisov are now too dim to actually track anymore, but the third object, 3I Atlas, is still on its way. It hasn't even reached its closest point to the sun yet, and it's not going to reach its closest point to Earth until it gets into November. So that's definitely still being tracked. And then into 2026, it's going to make its closest approach to Jupiter, and then it's going to head off into the cosmos. And then eventually it'll become too dim for us to be able to observe, probably in late 2026. But at the same time, the Vera Rubin Observatory will be coming online. This is this enormous observatory in Chile, which is scanning the entire night sky every few nights and is then going to be turning up anything that is moving. And one of the things that will be moving is going to be interstellar objects. And it's expected that it will find probably a dozen interstellar objects every year. And so we'll go from finding one every few years, I guess finding one every never, when we first found Oumuamua, to then knowing about two, Oumuamua and Borisov, then to knowing about three. We will suddenly know, we will be thinking about 5 to 10 at a time that are on their way through the solar system. And there will be bigger ones, there will be smaller ones, there will be faster ones, there will be slower ones. And we will be sort of keeping track of a whole bunch of them. And then we will stop getting really excited about interstellar objects, about every single interstellar object. We'll start talking about the fastest one, the biggest one, the smallest one, the one that's come the closest so far. We will start to think about their behavior and how some are giving off certain kinds of chemicals and others aren't. And then we'll start to see the trends and get a sense for this is what interstellar objects tend to be like. And then we'll be looking for the anomalies. We've seen 100 interstellar objects and they all had this in common. Well, those ones didn't have that in common. And we'll start to build this bigger picture of what other star systems are like out there, because we'll get this statistical information. And so you think about how often we announce the discovery of new planets. We don't, even though new planets are being found almost every day. Right? We know of more than 6,000 exoplanets right now, as well as easily 10,000 unconfirmed candidate exoplanets. And the rate of discovery is accelerating. And the same thing is going to happen with interstellar objects. Everybody's really excited right now about 3I Atlas. And it is special because it's so big, because it's so fast, because it's exhibiting unusual properties. But it will just fade into the background. And my guess is that we'll get to a place where we don't even talk about new interstellar objects that are being discovered, because it's just happening all the time. And then Tim, you asked, when are we going to be getting the 3I Atlas Mars images? We already did. I actually shared the images from Perseverance and the ExoMars mission in the latest video that we did. We're going to have to wait for the government shutdown to end to see the ones that come from the Mars Reconnaissance Orbiter, if it even took pictures. Like, it might just be that the staff were not allowed to work with the mission during the shutdown, and so then no pictures were taken. But my guess is they knew this was going to happen. They programmed it in, and the data are there somewhere. Haneskits, if there are interstellar comets, are there also comets from other galaxies, maybe thrown out of their galaxy? And how would they be called? Yeah, there is almost certainly intergalactic comets passing through the Milky Way right now. And this comes from the fact that we know that there are objects that are on intergalactic trajectories. They are on an escape velocity from the solar system. We know of hundreds of stars that are speeding out of the Milky Way, that they're never coming back. They've exceeded the escape velocity of our galaxy. And so you can assume that the same thing is happening in Andromeda, the same thing is happening in other galaxies. And as those star systems are being ejected out of their galaxies, they are taking with them planets, comets, asteroids, things like that. And then the processes that cause comets to escape from star systems are also going to be happening as they enter new galaxies. And then also you're going to get things that are getting kicked. They get into three-body interactions, they get too close to a black hole, and they will receive a boost and they're sent on an interstellar trajectory. But when you think about the volume of space, the random directions that an intergalactic comet could be sent on, there's a lot of space, not a lot of trajectories that are actually intersect the Milky Way. And then when you think about the size of the Milky Way, what are the chances that one of them is going to be passing through the solar system? So, I haven't seen any estimates on the number of intergalactic objects that are passing through the Milky Way or that are passing through the solar system. It's probably happened. There probably have been objects that have passed through the solar system that came from another galaxy, or maybe not. Again, I don't know what the math is on this, but it is definitely not impossible. And what's kind of interesting is that, if you kind of go back to what's the playbook of an advanced civilization that is looking to explore as much of a volume of space as they can, the power move is that you build von Neumann probes and you accelerate them up to close to the speed of light, and you send them at other galaxies so that you can reach places before they fall over the cosmic horizon and they're inaccessible to you. The sooner you get going, the better. And so probably the majority of objects that are able to cross these gulfs between galaxies were sent by advanced civilizations because they had a plan. They sent a target. And so it could very well be if we detect an object that is coming in on on an intergalactic velocity, right? Some object that is passing through the solar system at 1,000 kilometers per second, right? Then maybe that came from another galaxy. And if it did come from another galaxy, maybe that's the one that's the alien probe. Or maybe it's just a rock. Ed, why do cosmologists never address the origin of the fields the Big Bang originated in? I don't really understand the question because cosmologists address everything they can think of all the time. And so if you go and read archive, you look at the science papers that various scientists are writing, if you go and look at the journals of astrophysics, astronomy, and so on, you'll see a ton of papers about trying to address the conditions that led to the Big Bang. You'll see things about the scalar field and the inflaton and gravitons that you will see all kinds of papers that are regarding what the conditions for the universe could have been like before the Big Bang. And the challenge, of course, is that our theories about the universe sort of end at the beginning of the Big Bang, at the beginning of time, that it's really difficult to extract any useful observations out of the universe as it existed before the entire universe was kind of wiped clean and you got all of the conditions of the Big Bang. We can, when I say we, I mean scientists, can replicate the conditions of the Big Bang in the largest particle accelerators, and they can take them all the way back to just fractions of a fraction of a second after the Big Bang. You can replicate the conditions, the heat, the energy level of the various particles. You can watch as the fundamental forces merge together into combined forces like the electroweak force and the grand unified force. And you can then start to theorize about how gravity might have played a role in that unification of these different forces. But it's really hard to go one step further. That nothing that we can do, that we can replicate and simulate in the lab, can take you further than that. And yet, here we are, right? Where did the universe come from? Why is there something and not nothing? Like, this is a fundamental question that people are going to be asking. But what is your answer to that question? What is the method you use to determine the answer to the question, right? For people who will sort of take a religious perspective on this, it's super easy, right? They say, look, God made it. But that doesn't provide any explanatory power, right? What is your evidence that God made it? There's a book, okay, right? Is the existence of books all that's required to prove a theory about the cosmos? No, right? Is Harry Potter a reliable way of describing the existence of the universe? So it may very well be that it is impossible to derive any information about the nature of the cosmos before the Big Bang. That all we can do is start at the Big Bang and go further and go ahead. Or it might be possible that there is some kind of shadow, some echo, some after effect from whatever the state of the universe was before the Big Bang, imprinted and embedded into the current universe. And after a while, people will come up with theories. They'll make observations. They'll realize that there's some kind of echo for what the universe was before its current its current iteration. And that you can start to then make progress into what were the conditions before the Big Bang. But that still pushes the question back, because then you're asking yourself, okay, what caused that? Where did that come from? What came before that? And eventually you will have no way to make progress, no way to go further. And once you reach that place, you just have to be comfortable in saying, we don't know. And we probably will never know the answer to these questions, that we will have to live with the uncertainty forever. And that's fine. But, if you're saying, if you're positing, if you're claiming that cosmologists aren't interested in the conditions before the Big Bang, that's bananas, because you just have to go and look at all of the papers that are being published every day in cosmology, high energy physics, especially in archive, in places that are, pre-press review. And you will see a couple of papers every single day on this topic. And then people are challenging those ideas. And some percolate up and make it into the wider area, ideas like inflation, or cyclical models of the universe. But yeah, to just like assert, why don't they like that? Like, I promise you, they are very curious about this as well. Anonymous skeptic. If we can look at other planets far away and then get their composition, gases, etc., what would the Earth look like from another galaxy? So, we can barely gather the faintest hints of information about planets that are within this galaxy. a few hundred light years away is about the limit of what we can do to really measure the atmospheres of other exoplanets. So what would the Earth look like in another galaxy? It would be impossible for us to detect. And so I think, I'm assuming that you're asking what would it just look like from another star system? Like if there was an alien civilization that was 100 light years away from us and they were looking at us with their current technology, what would they see when they tried to look at the Earth? And the answer is they wouldn't be able to see anything. That our best technology today cannot separate Earth from the sun. That the brightness of the sun is 10 billion times the brightness of the Earth. And the highest resolution telescopes that we have do not have coronagraphs powerful enough to block that light from the sun. Now, if the sunlight was blocked, then we could detect the photons coming from the Earth. That's within the capabilities of these telescopes, but the sun is way too bright. And so currently our technology will require, or to be able to make those observations, we're going to need to block the light from the star to be able to make the Earth visible. And so that's going to require a coronagraph. And the James Webb has a coronagraph on board, something that blocks the light of the star, but it's not powerful enough. And so the upcoming Nancy Grace Roman telescope is going to have a better coronagraph on board. It's going to be able to distinguish Jupiter's orbiting sun-like stars, but that's not enough to be able to see Earth's orbiting sun-like stars. So it's going to require an even better coronagraph. And so there's some ideas to improve the coronagraph technology on the telescopes. And then the other idea is to launch a starshade, some kind of free-floating flower petal-shaped object that flies about 10,000 kilometers away from the telescope and perfectly blocks the star while leaving the planet visible beside it. And then that's what it's going to take. The other possibility is that you shift your wavelengths into the infrared. So the brightness difference between a star and the planet is only about 10,000 in the infrared and not 10 billion. So that is definitely possible with a coronagraph. But the problem is then you need a telescope that is about 21 meters across. And of course, James Webb is only 6.5 meters across. You need a telescope that is much, much bigger than what our biggest telescopes are today. The one possible telescope that could make those kinds of observations is going to be the upcoming the extremely large telescope. The one telescope that could do this is the upcoming extremely large telescope. It's going to have a 39-meter mirror. And so that is big enough to be able to resolve the separation between the planet and the star. It's also going to have a very powerful coronagraph on board that should be able to block the light from the star. And so maybe if other civilizations had built the extremely large telescope or something bigger, then they could detect the presence on Earth. And the things that they would be looking for would be chlorofluorocarbons. They'd be looking for industrial pollutants in our atmosphere. That's the clearest giveaway that there is intelligent life here on Earth. But then there's going to be able to detect other stuff: carbon dioxide, methane, ozone, oxygen, and start to build up a map of the gases in the atmosphere to try to determine if there's even life on planet Earth. But right now, with our technology, we could not detect ourselves even around Alpha Centauri. No me. As we know, there are tons of rogue planets, so do we still need a Planet 9, or could a rogue planet drive-by have caused the disturbance in orbits? I don't know whether the researchers have ruled out whether it's it has to be a planet in orbit or whether it's a rogue planet. But what you've got is you've got sort of like a clear shepherding of objects in the outer solar system, that the orbits of the objects appear to have interactions over long periods of time with some gravitational object. And so that's not the kind of thing you get with a one-time fly through the solar system. That's what you get through multiple interactions as things are orbiting around. So I think what they're looking for is an object in the outer solar system. John Radamus, I want to know why telescopes give us amazing quality photos of things that are very far away, but a very low quality of things like 3i Atlas. Just your opinion. Well, so you can do this experiment for yourself. Walk outside and look around, and then look at the things that are very big that you can see with your eyes, like houses, buildings, trees, things like that. And then notice that you're having trouble seeing things that are very small, like microbes, bacteria, insects that are a little too far away, but at the same distance as these objects. So the problem is, and then do this at night. Like, to really do this right, do it at night. Go outside on a dark night, and then notice how you can see houses, buildings, but you can't see objects that are not illuminated. And so when we look out into the universe, the things that are easy to see are the biggest things and the brightest things. And the biggest and the big bright things are the easiest. The galaxies, right? A galaxy can be 200,000 light years across and contain 400 billion stars. It is a searchlight, bright, shining out there in the universe. Here in the solar system, here on Earth, you look up into the sky, you see stars. The stars are stars that are actually a lot bigger than the sun, a lot brighter than the sun, pumping out radiation. They are dozens, if not hundreds of light years away. And yet you can't see with your eyes Pluto, because it is not putting out radiation. It is reflecting faint amounts of sunlight. Yeah, okay, it's putting out some infrared radiation, but it's mostly it is reflected illumination from the sun. And so a comet is small, 1 kilometer. Like, a comet could be 1 kilometer across. Now, in the case of 3i Atlas, it's 5 kilometers across. But think about that, right? 5 kilometers. That's like a mountain. But that mountain is 1 billion kilometers away, right? It's very, very small, and yet we can see it. In fact, you can see it with a backyard telescope at this point, although you can't right now because it's behind the sun. But normally, you could see this object in a telescope that you can have in your backyard. And so what we can see out there in space depends on, are these things putting out illumination? Are they gigantic, like galaxies, like stars? Or are they only visible in reflected light, like planets, like comets, like asteroids? And are they small? We know of moons of Jupiter that are 1 kilometer across, which is tiny, right? And we're looking at hundreds of millions of kilometers away, and yet we can detect these tiny little moons in the faint reflected sunlight, and yet we can find them. But it's tough. So you're not going to get clear images of these things that are tiny and not putting out their own light. Tian spans. 3i Atlas is growing a tail. Will any of the tail remain in our solar system? If so, how much? That's a really interesting question. It's actually a question that my wife asked me last night, which I sort of just kind of think about this. So 3i Atlas is buzzing through the solar system, and it's going 48 kilometers per second. And so it is shedding debris, but that debris is moving with the comet. And so it also has the velocity of the comet. Now, it's changed a little bit by the solar wind, by radiation pressure from the sun. And so it's forming a tail away from the sun. And yet that stuff is still moving at the same velocity as the comet is, but like a little bit off and a little bit different. And so it's still going to move through the solar system. And so will the material, and so then the question, so it'll be like this trail, like once the tail started to form and the sublimation was starting to happen, then you were going to get this material coming off of it. But then that will travel with the comet out of the solar system again. is sort of like the what I was thinking about, which is different from, say, a periodic comet that's here in the solar system that is sort of moving around inside the solar system. It's putting out bits of debris, but that debris is following the orbit of the comet around the solar system, and then the Earth can pass through that tail, and we see meteor showers. But I think with the stuff that's coming off of Triangulus, it's going to remain as this blob that's then going to continue to shoot off into the galaxy. But if you tell me if I'm wrong, because that's sort of the way I was sort of thinking about it. King Tad 1136. Do we know where on the planet Theia hit Earth? I don't know what LLSVP means. Let me see what an LLSVP is. Large low shear velocity provinces. Yeah. So to your question, King Ted, do we know where on planet Theia hit Earth? Not that I know of. I know that there are chunks, the interior of the planet is not completely evenly distributed, that there are anomalies in the sort of the shape of the mantle and the shape of the core. And you wonder, are those all the way back to the collision that caused Theia? But it was, or the collision that caused the moon, but it was a gigantic collision. It was an object the size of Mars crashing into Earth. It liquefied the Earth, and the debris was liquid and then formed into the moon. And so, are there lasting scars? We don't see it on the surface for sure. We don't see examples of craters that are that old and that big. The processes on the surface of the Earth are too rapid, right? We have plate tectonics, we have erosion, we have all kinds of weathering that happens across the surface of the planet. And so even very large craters are wiped away over geologic time. But is there a scar left over from, internally? I don't know the answer to that question. That's interesting. Brady Cox, I'm curious, what kind of watch are you wearing? I'm wearing a Garmin Phoenix watch. So the 8, which is the new one. I had the 4, and it was on its last legs, and so I got the newer version. And it's great because it has a GPS and lets me sort of calculate my heart rate while I'm doing hikes and stuff like that. And my wife gave it to me as a birthday present. Nothing I would ever buy myself. Let's see. Jazz D, do you think technological civilizations currently exist elsewhere in the universe? So this is a good example where I violate my don't have an opinion perspective, and that's only because there's no evidence that there are technological civilizations out there, and that our instinctual answer is to say, of course there are, right? How could there not be? That's ridiculous. What kind of self-centered species thinks that they're the only technological civilization in the universe? If life is here, life is everywhere. And then that runs up against the Fermi paradox, which says, okay, so where is everybody then? Right? If life is everywhere and we're potentially going to explore other star systems in the future and eventually build a giant galaxy spanning civilization, Star Wars empire, foundation like empire, then why don't we see that? Well, why don't we watch as civilizations are starting to have a serious effect on their galaxies? And I think, then people come up with a whole bunch of ad hoc answers. Well, like it's really complicated, it's really tough, and it's really far, and we've only started to look, and why would they even want to do that? And each one of those has answers. Each one of those has pushbacks as well. It is a complicated and very difficult philosophical question to unravel. That is a scientific question that, if there was some... if we detected a signal coming from another civilization, if we could resolve a Dyson swarm around another star system, if we could detect a galaxy that was being reorganized with Shkadov thrusters into a better arrangement to support the needs of an advanced civilization, we would have unequivocal proof that there are other technological civilizations out there in the universe, but we don't see them. Right? That everything we have is that it appears from our perspective that the universe is a wilderness, that it is untrammeled by intelligent civilizations. But that's not evidence either. Who knows? So my perspective is that I personally consider that the fact that we don't see evidence of advanced civilizations anywhere, and at the same time think that we're going to be able to head off into the stars, and that we know that the universe is much older than the solar system, and there's we're unlikely to be first. That for me is very significant evidence that we are probably that life in the universe is rare and perhaps even unique, and that. The way to have it not be surprising that you don't see evidence of advanced civilizations out there is if you're the only one, which is, of course, again, impossible, incalculable, inconceivable, right? And yet that's what we see. So the way I sort of justify this to myself is I say, let's really try to look. You can't just take it on faith. You can't just assume that we are alone in the universe. We've got to search. We've got to build telescopes. We've got to scan the surface. We've got to dig into Europa. We've got to look for life every way that we can think of it to try to find out. And if we, over time, explore an expanding sphere of the universe and we continue to find nothing, then the evidence starts to update towards the possibility that we are alone in the universe. And then that has implications, right? If we're alone in the universe, then we should think about what the future holds for humanity, because the future of humanity actually includes the future of the universe. So I personally, if I had to sort of place my bets, I think we're alone. But, and that we should put a lot of energy into proving me wrong. Prince Charming the First. What is quintessence? Is it still used in cosmology? I don't really know. There's a cosmological version of that. In physics, it's a hypothetical form of dark energy, more precisely a scalar field minimally coupled to gravity, postulated as an explanation of the observation of the accelerating rate of the universe. So it is a sort of possible explanation for dark energy. So some people use it, but not many. And then there's like an older version of quintessence, which is sort of proposed as an early, I don't even know what it was, like back like alchemically. And so that's not a thing. But there's a sort of version in the understanding dark energy where they use a term called quintessence, which is probably a terrible move, right? Like, why would you use a word that is like would be calling like you're searching for some understanding about stars and you propose, was it phlogiston? Right? It's crazy. It's offline. Say, hypothetically, Theia were to be an alien spacecraft. What measures do we have in place to study it or encounter it? We have the normal measures, which is that we have the ability to study its movement through the solar system. We can use James Webb, we can use the Hubble Space Telescope, we can use ground-based observatories, and we can analyze its chemical nature, watch its movements very carefully. We can use giant radio telescopes to scan for any kind of signal. Like if there was like a cell phone on the surface of Theia, we would be able to detect the radio transmissions coming from it. Now, we don't have any ability to intercept it because we don't have anything out in space right now that could sort of put the, we don't have anything in space right now that has the delta V, the propellant capable of intercepting it. But there are plans in the works to catch the next one. And so in 2029, the European Space Agency is going to be launching the Comet Interceptor, and that's going to be a mission that's going to loiter out at the Earth-Sun L2. That's going to loiter at the Earth-Sun L2 Lagrange point and wait for a target like this. And then when one comes within its sort of capabilities, it'll have enough propellant to be able to execute a flyby. It will fire its thrusters and then try to fly right past the object. And so the way this is going to play out is Vera Rubin will come online in a couple of months. In 2029, we'll get the Comet Interceptor mission. Vera Rubin will be detecting a dozen or so interstellar objects every year. And when one with the right characteristics is found, when one with the right characteristics is found, then the Comet Interceptor will fire its thrusters and begin an interception maneuver, and we will see up close an interstellar object for the first time. Generational hater. Who are your favorite space and science YouTubers besides yourself? Well, there are many space and science YouTubers that I much prefer to myself. You've got to have aspirations, right? So like every time I do this, it's off the top of my head, and I apologize because there's just too many names. So I think, my absolute favorite, what I consider to be the sort of gold star, is people who have an advanced degree in a relevant field, but are also putting a lot of energy into actually sharing this information. And so, for example, you've got Moya McTeer, who has a podcast, but she has her PhD in astronomy and has written books about this, and yet is doing a publication every, is doing a podcast every week. You've got Dr. Becky, who again, PhD, astrophysics, and yet is taking the time to explain black holes to us mere mortals. You've got PBS Spacetime, Matt O'Dowd, who again is a genuine researcher, and yet taking the time to explain this information to us regular people. You got David Kipping, Cool World Channel. He is leading a team of researchers searching for exomoons, and yet takes the time not only to report on his work about exomoons, is also explaining cool, weird theories that he's having, but they have a scientific basis. And he's talking about the Fermi paradox and things like that. Space Mog, who has a PhD in astrophysics and is researching dark energy, and yet she takes the time to explain all of this stuff to us. So I think if I was sort of like make a tier list, it's like people like that, where they have, I always talk about how I don't have the experience. I don't have the training. I can't provide any additional information beyond the scientific consensus. The superpower that these people have is that they actually went out and got the credentials. They got the degree. They spent their time. They did their diligence to gain the knowledge to understand from the level that that their cohorts are at, but are also realize that they have this responsibility, or they feel this responsibility to share this information with the public. And that is so precious that, you know, it's what Carl Sagan was like, right? Carl Sagan was working on missions. He was a planetary scientist, and yet took the time to share this enthusiasm. He took the time to share this with an enthusiastic public. So they're kind of like my A-tier people. And what, you know, I think hopefully we can build and encourage more people who both have that degree, have that specific technical training, and also want to follow that sort of drive to share that information with the public. And I think, you know, my role here, hopefully, is to find the people who have the knowledge, who are, you know, PhDs, who have done the work, who have advanced our understanding of space science in some way, and who have an interest in doing communication, in sharing this with the public, dumbing it down for the rest of us. And I can give them a platform. I can help them both sort of give them practical experience in being able to share their information, and get them a wider audience. And if that's, you know, if they get a bug for it, if they really enjoy it, if they catch the interest, the hobby, then maybe they'll do more of it, because I think we're better served. The more the scientists who are actually doing the work are able to communicate their information, the better we all are. So, you know, I make this case a lot of the times, right? Like I am driven to help scientists communicate their work and help them find their voice as a science communicator. And so, you know, if you're watching this QA and that's you, feels like you, right? You are doing research and you have a sort of passing interest in doing science communication. You wonder what it's like to be able to communicate this information. Let me help you become a YouTuber. So yeah, hopefully. James Davenport is another example of, you know, he's a like actual exoplanetary researcher, and yet does videos here on the channel about his work. So yeah. Anyway, that's what I consider to be the best of the best of the best. Wow, tons of questions. So many questions. Okay. The Flume Maca. If a person jumped into a supermassive black hole, would their soul be trapped or destroyed? It depends on whether the soul is part of the body. It depends on whether the soul exists or not. You know, for me, there's no evidence that the soul exists. But if the soul does exist, is it attached to the body? If it is, then it is also destroyed or trapped forever in the black hole until the black hole evaporates and the information is destroyed somehow. All right, where are we at? Wow, an hour. Okay. Steve B, how large would a bucket of water have to be to put out the sun? So you can't put out the sun by throwing water on the sun, because the problem is that if you feed water to the sun, water is made of hydrogen and oxygen, it would heat up and would break into plasma of oxygen and hydrogen, and then that would be added to the sun. And what do you get when you add hydrogen and oxygen to the sun? You just make it bigger and hotter. So you increase its mass, it has more fusion at its core, puts out more energy, and you could just keep adding more and more water. And eventually you would get to a place where you've added so much water to the sun, or added so much hydrogen and oxygen, that you're just dramatically decreasing its lifetime. And so instead of it lasting 4.5, instead of it lasting like another, 6 billion years, it's going to last 1 million years. But then it's going to explode as a supernova. So there's no amount of water that you could put into the sun that would put it out, because it's not a fire, it's fusion, and fusion loves to get more atoms. Splurge, whatever happened to last year's nova in Corona Borealis? Did it ever flare up? No, we haven't seen it flare up yet. It's getting weird. Wandering Fool, is the galaxy a graveyard? Is there no alternative? I I don't know if I entirely understand the question, although I really enjoy the question. It's a very kind of poetic sounding question. And so I'm going to just interpret the question. And hopefully the way I interpret it is the way you were intending it. Which is that the galaxy, the Milky Way, is producing about one star on average per year. And we are way beyond a time called cosmic noon, which is when the galaxy was in the most sort of the highest rate of star formation. That now everything is just settled down, and in fact the galaxy is dying. We are using up all of the stores of gas and dust to be able to create new stars, and that rate of star formation is going to decrease. You will get this brief period when we collide with Andromeda or collide with the galaxy in Triangulum, and you'll get a sort of surge of star formation again, but then that will settle down as well. And then that will be it. Those will be all of the galaxies that are going to merge with us, and so we will turn into a giant elliptical galaxy like M87. And then we will become red and dead. And over time, the hottest, brightest stars will explode as supernova, turn into black holes, neutron stars, and then stars like our sun will wrap up their lives and turn into white dwarfs. And then stars that are smaller than our sun, red dwarfs, will eventually fully use up all of the fuel inside of them, and then they'll just cool down to the background temperature of the universe. And 100 trillion years from now, the Milky Way galaxy will be dark, because there will just be almost no star formation anywhere inside of it. And that is the fate that it's going to be facing all of the galaxies out there in the universe, that we are way beyond the party, cosmic noon, about 2 billion years after the Big Bang, that everything is now just settling down and going quiet. It's going to take a while, but not forever. And there will be a time in the far, far future where there will be no usable energy anywhere. And that's the heat death of the universe. And then things will probably continue forever in this place where nothing interesting will ever happen again. Okay. Alex Channel, do you think we'll see aliens first or find their signals first? I mean, I have no idea, but we should be doing both. So for seeing the aliens first, we're going to be developing next generation telescopes that will allow us to measure the atmospheres of planets in the habitable zone of their stars, looking for the kinds of chemicals in the atmospheres that could indicate that there's life there. We're going to be searching around the solar system for any evidence of life that's not on Earth. For their signals, we should be listening. We're going to have giant radio telescopes that are going to be listening on wavelengths that we think that civilizations might be attempting to communicate with us. We're going to be scanning places here in the solar system to look for anything that is artificial in origin that maybe is evidence of a a von Neumann probe or an interstellar spacecraft. We're going to be looking for that, and which one of these is going to turn out first, we have no idea, which is why we have to sort of cover all of our bases. Bali. The telescopes are off the shelf, perhaps in position for use. Yes, I was using the telescopes last night. I took images of, I was able to compare the Sea Star against the Vespera 2. And so I'm going to be sharing some pictures that I did probably in the QAs this week. So stay tuned for that. Good eye. Wow. Very impressive. Leland Palmer, Fraser, the lost iron from 3i Atlas may have been found. Iron and nickel are now roughly being emitted in equal numbers, according to a recent paper on Archive. Please comment on the lost iron. Yeah, so this paper came out. We did this big episode on 3i Atlas last week, and literally after we finished recording, I was going through the papers, looking at what we were, the stories to cover, and there's the story about now the iron is being produced in ratios that are related to the nickel. So that'll have to be next week. So it's just like, this is how this works, right? This information is just coming out all the time. And so things that are anomalies either continue to be anomalies or they work themselves out as more people, more eyes are on the target. So yeah, we'll cover that in Space Bites this week. TV, so hear me out. What if 3i Atlas was a semi-failed experiment involving space trebuchets? I mean, if your goal was to send an object at another star system, I think it was not a failed experiment. You did a great job. Ray Cornelius, how large and how close would an object have to pass the Earth to perturb satellite orbits? I mean, I can't do the math here in a live stream. So it would have to be pretty large and come pretty close to perturb solar system, like probably within the orbit of the moon, and it would have to be probably tens of kilometers, if not hundreds of kilometers across. Stay Mull. Can I ask, will new data become private on 3i Atlas, do you think? No information is going to become private on 3i Atlas. Got to understand that this is a network of astronomers using a network of telescopes. When I did the video about 3i Atlas this week, I rattled off a dozen different observatories in different countries that are observing, as well as space telescopes. So this is not one nation that is jealously guarding information about this comet. This is independent astronomers working with independent observatories around the world, reporting their discoveries independently. There is no central planning service, any of that. That you could go out right now, you could take your telescope, you could point it at 3i Atlas, you could make observations, and you could announce your findings, and no one's going to stop you. So no, the science in general wants to be as public and transparent as possible. And generally, especially astronomy, people are reporting this stuff just directly out to the public all the time. There's almost no situations where the information, there's no situation where the information is maintained private forever. There's a few situations where information is gathered by a telescope and it's embargoed for a period of time for the researchers who requested the time on the telescope to be able to do their paper and write up their work. But if they blow through the limit, then that information is then publicly released anyway. So, like when you think about how these things are discovered, they're discovered often by amateurs and then confirmed by other telescopes, and the news is already out there. So no, none of this is private. It just happens to be that the government was shut down when a lot of the best observatories were going to be able to try and take a look at it in the US, and that's a problem, but it's also a problem in many other ways for the US government. Okay, I am, where are we at now? Okay, all right. SSA Laura, are you planning a year 3 of James Webb show? Probably not. Um, just because I think people are less interested. We'll probably do a year 1 of, say, Veer Rubin. So just whatever is the cool new spacecraft, cool new telescope. That's what all eyes are on, and we're going to try and provide that information. Paige Potter, if you could ban one space cliche from movie scripts forever, what's getting launched out the airlock and why? I can't. I mean, no, for me, space movies, science fiction movies are not science. And so I try to turn off the part of my brain that is seeing them from a scientific realism standpoint. So we watched a movie last night, my wife and I, called The Moon, and this is a Korean movie, and it's kind of like the Korean version of The Martian, where the Koreans send their first human lander to the moon, and disaster happens and all kinds of problems happen, and then there's international attempts to try and save the lives of the people involved, and it started off strong, and it was clearly written with somebody with a lot of advanced aerospace knowledge involved, and then it just ignored their advice, right? And just said, the person says, okay, but like, how could we have the spacecraft crash on the moon? And the aerospace person was like, you can't. It's going to be going, and 100, it's going to be going whatever. It's going to be going a kilometer per second, and it would just be destroyed. Yeah, but okay, forget it. We're just going to have it happen. And you're like, fine, right? Obviously, you're not going to listen to me anymore. So, and at a certain point, my wife was rolling her eyes. I was rolling my eyes. We were both pulled right out of the movie because it had just violated so much of reality, and yet tried so hard to seem really realistic about the kinds of technology they were using, the way people were speaking, a lot of it was done really well, and yet enough of it was done poorly. So I think for me, that's the thing, is when it is done poorly. Like, it's done well in The Martian, and then you have something like Gravity, which sort of starts to try to be doing a good job, but makes enough mistakes that they feel jarring. And then something like The Moon, where they, again, try to do a good job, and then it's very jarring. But if they're just going to go straight into cliche land, and you've got anti-gravity, and you've got teleporters, and you've got spacecraft that fly like fighter jets, I don't care. Totally fine. Bring it on. Because it's no longer feels like science to me, and then I can just detach that part of my brain and enjoy the movie. It's like, one of my favorite space movies is called Space Sweepers, and it's another Korean movie about garbage hunting, a crew of garbage hunting astronauts, and it's no part of it is realistic, and it is bonkers, and I love it. And it's one of my favorite space movies because they didn't try to be realistic. Happy Thanksgiving, Whiskey Canuck. Quirto was Nico Girl. Still curious if there are any updates about the leopard spots and poppy seeds on Mars. There haven't been any updates. So, probably, there'll be a few more updates, but really we won't be able to know until the Mars sample return mission brings that sample back home to Earth. Cambos Tepe, why are we not seeing a lot more observatories launch into space with the cost so reduced in the last 5 years? Because the launch costs are only part of it. And, there are a lot of missions that have been launched because the launch costs have been decreased. The cost of, say, launching a spacecraft on a Falcon 9 is what, 60 million ish, 90 million on a Falcon Heavy. In the olden days, it was 200, 300 million to launch on a Delta or an Atlas. So that's a huge cost savings. And so you're seeing a ton of missions. And there have been a lot of space observatories that have been launched on, we have the SphereX, we've got the TESS mission, we've got, I can't even go through all of the recent observatories that have been launched. Maybe you haven't been sort of watching every single one of them, but it's probably been 5 or 6 observatories a year that are being launched. And a big part of that is the decreased launch costs. It's the big ones, the big flagships. Then the launch cost doesn't really matter that much compared to it. Like the Hubble Space Telescope was launched on the Space Shuttle. James Webb was launched on an Ariane 5 rocket. And it cost $10 billion to build, and then a few $100 million for the launch costs. So, as you move towards a flagship mission, those launch costs become less and less relevant compared to the development costs of the observatory. And now you're in this time where almost every single major mission is either experiencing delays or cancellation. So in the U.S., what's the necessity of bringing those launch costs down if none of the missions are being funded? Emily Tarver, what's the most cinematic moment you've ever experienced in real life while covering space news? I watched a rocket launch. I watched the OSIRIS-REx mission take off. That was pretty amazing. So yeah, I would say that, experiencing a rocket actually take off is, fantastic. I highly recommend it. And it's a thing you can experience. Like you just can go to the East Coast of the United States, go to Florida, stay in, land in Orlando, drive out to the Space Coast, go to the Kennedy Space Center, and then watch a rocket take off. They're going every couple of weeks at this point, sometimes a couple of times a week. And so your chances of watching a rocket take off are pretty high. Whiskey Canuck, are you a person who considers science fiction and sci-fi as 2 separate genres? No, they're the same. Annie Alexander, Fraser, have you thought about having a section of Space Bites for reporting findings from Chinese language articles? Or you're the only astronomy YouTube channel I know with the ability to report this news? I don't do any separate reporting for Chinese news that's happening. We just fold it into our regular coverage. So one of the things that I do, which not a lot of other even space reporting sites do, is I get all my press releases from the Chinese Space Agency. I read Xinhua. I'm sort of watching carefully about all of the developments that are happening. It's really tough. It's I have not mastered how to keep track of everything that's going on. I've not mastered how to keep track of everything that's going on in Chinese space exploration, but I do my best. And then we report on that in Universe Today, and then we cover that in Space Bites. And so, we could do a much better job. And I have put out a bunch of requests to various people in various parts of the Chinese Space Agency to do interviews with people working on their space telescopes, people working on some of their rockets, people working on their lunar landing program, and nobody's gotten back to me. So I think my next step is to probably go to China, set up interviews and see if I can actually interview some of the people behind this stuff and talk to them. So it is an unfolding, it is a weak spot in our coverage because it is, becoming more and more relevant to what's happening around the world. And it is a very challenging nut to crack, beyond just me learning how to read Chinese. It's, it's cultural issues, there's secrecy issues, there's, and I come from a country that is, not the United States. So, there's some level of neutrality, but still it's a tricky thing to do. So I haven't cracked it yet. And so this is one of the great challenges of my reporting career, is to learn how to accurately report on stuff that's happening in China. The very best person is Andrew Jones. and he does reporting for Space News, for space.com, and is sort of quite tied into events that are happening with the Chinese Space Agency. And so generally I sort of like look at the reporting that he's doing and then go like, how did he learn that? And then I sort of try to figure out, I try to reverse engineer his reporting to go like, oh, okay, I see. He was watching Baidu, or he was reading Weibo, and there was a bunch of channels that he was following on Weibo that were reporting on this. And okay, right, but it's a challenging thing to be able to do. So I think also there's Dongfang Hour here on YouTube, which is another channel that specializes just in what's happening in Chinese Space Agency. So I think if you want the best reporting, follow Dongfang Hour here on YouTube and seek out Andrew Jones' reporting on the web. Okay, I'm gonna shift into high speed mode here. Maybe we'll see. Emily Tarver, which is harder, keeping people excited about the slow, quiet missions or the calming hype around flashy ones? I don't care. I don't care what people want to know or want to hear. All I care about is what I'm interested in, what I'm fascinated, what I'm curious about, and the things that I think are underreported or the things that I think are most interesting. And my assumption is that if I find them interesting, other people are probably going to find them interesting too. And so that's what drives my coverage. I don't spend a lot of time trying to think about what people expect, because I find then you just cave to the majority and you stop being interesting and unique. So I just like, I don't overthink it. Like, it just like, if this is something that's interesting to me, this is something that I'm curious about, and so I report on it. This is something that is boring to me now, so I don't report. Like, I barely cover SpaceX launches. Like, yeah, we'll talk about Starship, but I don't talk about all of the regular Starlink launches that are going on, even though they're news. I just don't care. I just don't care. It's not interesting to me. So I've moved on. And then, it's a lot of other stuff that I just don't report on. And so, yeah. I think if you start to kind of think like, how is this going to be accepted? How's this going to be adopted? There are definitely times where, like with the 3i Atlas story that we did this week, the 3i Atlas video that we did last week, where you feel this rising frustration about the way something is being covered or the way something is being sort of explained in the media. And so you feel this urge to respond to it. And so then I just follow my instincts again, but I'm not trying to, so I don't have any larger plan. I'm not trying to craft some kind of consciousness about how people perceive the news or any of that. I literally just follow my curiosity, and that's it. Kevin Patrick, why is Uranus the butt of all jokes in the solar system? Because saying the word Uranus in English sounds like your anus, which is person's butthole. And that's hilarious when you've got the sort of, on the one hand, the rigorous scientific discipline of planetary science, and on the other hand, you've got poopy farts. And they come together in this sort of difficult merging in your brain. And you have to sort of, on the one hand, be awed by the majesty of a world covered in ice and rock and that has barely been explored by only one of our spacecraft. And on the other hand, it sounds like butts. That's so funny. Obviously. Silvercoin Ring Shop. Have you ever been approached to be in any sci-fi shows? Always thought you'd have a cameo in TTBT. What is TTBT? The Big Bang Theory. Ugh, I hate that show. No, never. Tiago Moreto, if Theia Atlas was heading towards Earth, how much time would we need to have to repel it? We couldn't stop it. Theia Atlas is 5 kilometers across and is going 42 kilometers per second. It is the size of the object that probably killed the dinosaur, and it is moving much faster than the object that killed the dinosaurs. And so we don't have anything to do. No amount of time would allow us to be able to stop it from hitting us. Kodai 23, when do you think we'll have boots on Mars? Will China beat NASA to it? No idea. I would say, if you listen to SpaceX, they're hoping to have people on Mars by the late 2020s, 2028 maybe, 2030. I don't believe them. I am skeptical. Fine, into the 2030s. End of 2030s. NASA currently has no plans to send humans to Mars. It's not official. So at that point, because there's no hardware, nobody's actually planning anything. That's probably into the 2040s. The Chinese are planning to put humans on the moon by 2030 and then probably planning to go to Mars after that. So I would say late 2030s, early 2040s, we should see Chinese boots on Mars. So it's, back to it being a race between NASA and China in the 2040s, or SpaceX in the 2030s. But, there's a lot of reasons why SpaceX will ultimately just not be able to pull it all together to be able to actually send humans to Mars. So I would say 2040s, mid to late 2040s. But who knows? Azure Knights, just finished reading Project Hail Mary. The film is coming out in 2026. What are you looking forward to seeing in the film in particular? I mean, nothing in particular. I'm just really looking forward to the movie. I think it's going to be great. Yeah, I'm every part of it. I really enjoyed the book in the way that I really enjoyed reading The Martian and then seeing The Martian turned into a movie. And so hopefully the Project Hail Mary will be like the book turned into a movie. So it's going to be with Ryan Gosling. He's great. They've already sort of explained the conceit that he meets an alien and they work together. That's great. The sort of jokey Andy Weir aesthetic is there. That's all great. Yeah, I can't wait. I'm excited. I'm hyped. Let's see. Oh, it's 58 kilometers per second. Yeah, sorry. Not for glory. Theia Atlas is cruising at 58 kilometers per second without disintegrating, and the theoretical limit is 300 kilometers per second. Actually, the theoretical limit is 300,000 kilometers per second, not 300. So there is no realistic speed limit. If we had an intergalactic comet passing through the solar system, it could be going 600 kilometers per second. So there's no, 1,000 kilometers per second is like the fastest star that's ever been seen, which is now approaching a fraction of 1% of the speed of light. So conveniently suspicious alibi. Fraser, do you think the Ramses, ESA's mission to asteroid Apophis, is likely to discover anything new? I know it won't hit Earth in 2029, but other than it being notably large, it doesn't seem interesting. Of course it'll discover things that are new, right? Like this is what you do when, if you send a spacecraft to an asteroid that's going to go into orbit and follow that asteroid as it's passing by the Earth, going through a flyby, you are going to discover new things. You're going to discover things about the composition of the asteroid. You're going to discover things about how asteroids interact with the Earth's gravity well as they come uncomfortably close. You're going to learn things about the composition of the asteroid. Each time you send a spacecraft to a new thing, you discover new information. So yeah, I can't imagine how you wouldn't walk away with it going, well, we didn't learn anything new. You're going to learn a ton new. Roddy Piper, what is the shortest time it takes to go to Titan with today's technology? About, if you want to go to Titan, go into orbit and like actually land on Titan, about 10 years is what it takes with our current technology. Anonymous Skeptic, do wormholes really exist? Do you think we'd be able to photograph one someday like we did with a black hole? We have no evidence that wormholes exist. We have no evidence that they're stable. And so in order to discover one, you know, if it's been proposed that the way you could discover a wormhole is that you would detect an unusual brightening, that, you know, maybe that there was like a wormhole is passing and there's a star on the other side of the wormhole and you're suddenly seeing a star through the wormhole that wasn't there before. And so you'd be scanning the sky looking for unusual stars to appear out of nowhere, and that would tell you that there was a wormhole right in front of it. And people have proposed that. Nobody has seen this. Sega Savage Sounds. What is 3i Atlas? Comet or First Contact? Comet. Nicholas Moulis. Fraser, do you have a view on the upcoming NASA budget and the associated cuts? I'm against the cuts to the NASA budget. I think, you know, NASA space exploration is already receives limited budget compared to the other types of spending that go on in governments like military, things like that. So I wish that there was more money spent on space exploration and less money spent on fancy new ways to kill people. But I can't have everything I want. So at least don't cut the expenses further on existing missions that are already operational. That seems crazy to me, right? Why would you turn off Juno? Juno is doing hard work. It's out there. Why would you turn off the Voyagers? Why would you turn off spacecraft? Why would you scrap work on spacecraft that are almost complete? So I would start there personally. So no, don't cut their budgets. Wandering Fool, would you like to spend more time with your telescope? No, I mean, where I live, we don't get a lot of clear skies here on the west coast of Canada. We had one last night, which was great. I got the telescope out. But I'm a morning person, not a night person. And so I have a really hard time staying up past about 10 o'clock. Now, with the telescopes that we have, you can plan out your evening's observations. So you just set them out, plug them in, plan what you want to look at, and then you come back the next morning and they've taken all their pictures. That's perfect for me because I'm already asleep. So no, I want to spend less time with the telescope. I want to spend more time looking at the pictures that I took with the telescope. You know, spending time with the telescope is a hassle because you're just like having to fine tune things, having to, you know, wrestle with the telescope. And instead, you just want to be able to have pictures show up. And that's what these modern smart telescopes let you do. Church discography, you were banished from Earth. Where would you like to be sent? Somewhere that won't kill me, I guess. Which we don't know of any place in the solar system, so another star system, I guess. See, Jazz D, do you think the signs of life discovered on Mars are a result of panspermia or abiogenesis? So, you know, did they form on Mars? Like, are they life? That's the first question. And there's, you know, there's compelling evidence that there's no natural, no abiogenic way that they could have known. Although there's no non-biological explanation that the scientists have so far, doesn't mean that there isn't one. So, you know, you have to wait for that. And then is it panspermia or is it abiogenesis? Did it form? We don't know. We have to bring it home. And if we can somehow detect DNA in it, then we can determine if there's a common ancestor and then figure out if it's panspermia. And if it's life that works in a way that doesn't work the way life works on Earth, or we have no common ancestor, then it's abiogenesis. And that's really interesting too. So either one is interesting. So no, we have to get those samples back to be able to find out more about it, even if it is life or not. David, if you had to choose Ryan Gosling or Ryan Reynolds to initiate first contact, who would you choose and why? Ryan Reynolds, probably. I don't know what Ryan Gosling's real personality is like. I get a sense that I know a lot more about Ryan Reynolds. But then I grew up in the same city as Ryan Reynolds, right? He grew up in Vancouver, and so did I. And so, he's some. When I hear him talk, he talks like people I grew up with. So I feel like it's very familiar to me. So probably that's why he would be representing Canada to the alien civilization. Paige Potter, can you sense cultural differences between space agencies and how they talk about risk and failure? Um, Not maybe like a tiny little bit, but I think like in general, space agencies are so accustomed to large, complicated, multi-year projects requiring a lot of moving parts that it sort of builds in a level of institutional caution and risk avoidance in general. The one space agency that feels to buck that trend is the Japanese Space Agency. I always like really love how they're willing to do they're willing to try new technologies sooner than anybody else. They deployed solar sails, they used ion engines, they're willing to do sort of try new things. They've shot a tank. They shot a projectile at an asteroid. They shot a was it like a yeah they shot a anti-tank weapon at a asteroid. They deployed hoppers and little rovers and are planning to do a lot more of that in the future. And so, I would love, like, I wish I spoke Japanese because I could do an interview with somebody in the Japanese Space Agency to just understand that philosophy. What makes them so willing to try ideas and have those ideas be approved further up the chain in a way that we don't see that level of creativity and risk takingness from ESA or NASA. Victor O, how would an icy compact Victor OE, how would an icy comet impact differ from a rocky asteroid? It's the density of the object. So an icy comet is going to be less dense than a rocky object. So if they're the same size, then the rocky object is going to have more mass, and so it's going to do more damage when it impacts. It's thought that like when a comet impacts the Earth, if it's smaller, then it will actually explode in the high atmosphere and you get this air burst, which can be very damaging. It's thought that the Tunguska explosion in 1908 was the result of an airburst. And so instead of this thing hitting the ground and carving out a crater, it broke apart in the high atmosphere and just detonated. And that's the kind of thing you would get for something that is a pile of rubble as opposed to a solid block of metal or even a solid block of rock. So you get different effects. Airbursts are damaging, but while solid objects hitting the ground are damaging too. Nathaniel, buy astro binoculars now or save money for telescope. I would probably buy the astro binoculars now. A pair of 15 by 70 Celestron Skymasters are going to set you back about $100, but you can even pick them up on sale or pick them up used for half that price, $50, and they're an amazing pair of binoculars. Like, you can see comets, you can see the rings of Saturn, you can see the moons of Jupiter, you can see bands across the surface of Jupiter, you can see how the moon looks amazing, and then you can see a lot of other deep sky objects. You can see Andromeda Galaxy, you can see the Orion Nebula, you can see star clusters, globular star clusters. They're great. I really like my pair of binoculars, and then we use them for birding. So if there's birds out in the garden in front of us, we're able to examine them with the binoculars, and they're easy to use. So yeah, it's always go with that. And then I would probably go with like a 6-inch Dobsonian telescope when you can afford one. But even that, if you're more interested in just taking pictures, I would skip to like get a C-Star instead. as your like your first telescope. You know, it's funny. Like I was using the Sea Star and the Vespera last night, and the Sea Star is fast. It is really fast. It connects to my network directly, and so I can then control it with my phone or my computer or whatever. I don't need to pair it with Bluetooth or with Wi-Fi directly to the telescope. While the Vespera, I can't connect it to the telescope. Sorry, with the Vespera, I can't connect it to my Wi-Fi. I have to run a Wi-Fi on the telescope, and then I have to put my phone in a way that it accesses the Wi-Fi only from the telescope. And then I can't use my phone to look up stuff because now it's connected directly to the telescope. And so it can only be a controller for the telescope. I'm now just kind of ranting about the experience that I have. And the Vespera is very slow. You set it out and you start to go through this sort of boot up sequence, and it does focusing. It took about 15 minutes for it to get to a place where it could start taking pictures, while the Sea Star is done in a minute. When it's ready to go in about a minute from when you set the thing out, it's ready to start taking pictures. So yeah, so far, although the Vespera, the pictures are much better than the Sea Star, and I'll share those with you shortly, like in a couple of days. But just the ease of use, the Sea Star is an amazing little telescope, and the pictures are great. Like I was taking pictures of the Dumbbell Nebula last night, and they look great. And I was showing them to my wife, and I'm like, okay, here's one, here's the other. They've both been taking pictures for 30 minutes. Which one do you like better? She's like, well, I don't know. I think I like this one a little better. And that was the Vespera. So the Vespera takes better pictures, but from an ease of use standpoint, boy, I really enjoy the Sea Star. They've nailed it, just nailed it. And they're a fifth the price, right? The Vespera is about $2,500, and the Sea Star is $500. Yao de Carveo, are you interested in Beatriz Vero, I don't know how you say it, Via Rolls research? Yeah, a little bit. We've reported on her work in the past on Universe Today. She was the one looking for, I think, potential artificial objects orbiting the Earth before the age of satellites, and has done other work. And it's a way to look at the questions of UAPs and other UFOs, but with a scientific perspective. So yeah, I think, if you believe that the Earth is being visited, or if you even think it's a possibility the Earth is being visited by alien spacecraft, then that is a scientific question, and that deserves a scientific response. And so I think, if you're going to do that, that's the way you need to approach it, and not just assume with limited information that everything we see is aliens. Sorry, just looking for another question. Where are we at? 9:43. Wow. Kim Steinhaug, when Vera Rubin telescope is online, do I need a telescope? Oh, well, of course you need a telescope, because Vera Rubin isn't going to be able to let you look through the eyepiece and look at an object that's in the sky right now. You can ask that same question, right? If the Hubble Space Telescope is operating, do I need a telescope? Well, the Hubble Space Telescope is looking at what it's looking at, and you want to look at the things you want to look at. So there's something special. Like when you look through a telescope eyepiece and you're seeing Saturn for the first time, it should give you shivers. That it should be just blowing your mind that you're actually seeing Saturn. And like if it doesn't, then I've never seen someone not go like, wow, this is amazing. So there's just something special about looking at the stuff on your own that you can, otherwise you're just looking at other people's pictures. Why have a camera when you could just look at other people's pictures? Why do art when you just look at other people's pictures? Why write stories when you can read other people's words? So there's something about the creativity of using these tools to explore the night sky that you don't want to be a passive observer to other people's work. You want to do it for yourself. Nova Castre, did you ever watch The Sky at Night with Sir Patrick Moore? I didn't. No, it was never aired in Canada in a way that I had access to it. So I know there's a lot of shows that were very space related, but are very BBC related. And so a lot of us outside of the UK have never seen them. Jay Garrick, would you desire Ryan Reynolds to represent Canada, the aliens as Green Lantern or Deadpool? Obviously Green Lantern. Will Pike, what sci-fi books do you highly recommend? I'm in the process of building my list of sort of the science fiction books that I recommend. I'm actually building, I recommended my top TV shows and my top movies. I'm probably going to maintain a list of my top sci-fi books and my top video games. And I'll sort of maintain these lists, probably about 100 of each thing. I don't know if I'll have 100 video games. Maybe. I don't know. But I'll have like my 100 favorite books, my 100 favorite movies, my 100 favorite TV shows, and try to provide a nice comprehensive list at some point. So I'm working on this bit by bit as I think about things. I think, you've sort of got to take your time. You can't just rush a list. So I'll let you know. But like right now, what I recommend, I highly recommend anything by Alistair Reynolds. I recommend anything by Ian M. Banks. Andy Weir is great. Then you can go back and read classic stuff, Isaac Asimov, Robert Heinlein. I'm really enjoying rereading Roger Zelazny books right now. And then there's like too many to count. So the We Are Legion, We Are Bob, the Bobaverse books are terrific. Yeah. So I really should get this written down so that I can have a very organized answer for this question, as opposed to whatever I've most recently read, which are the Dungeon Crawler Carl books. All right, let's go back up to the top. Hi Mars, if interstellar objects were sampled by an alien civilization in another star system, could they still carry any evidence of being interfered with despite traveling for billions of years? I mean, it depends. Like, we wouldn't be able to sample it just we wouldn't be able to detect their modification. Although, unless it was like really big. Like, okay, so if an alien civilization made an interstellar object and they made it a board cube shaped, then we would detect that. It would be obvious. Or if they put some kind of transmitter on it, or they gave it thrusters so it could change its orbit, then we would detect that. But if it just looks like an asteroid, then we would have no way to know the difference. Or a comet. Casey, you're asking a bunch of questions that I just don't know the answer to. You ask them every week, and I don't know the answers to them, and I'm sorry. Like, I don't know about the T-38 hours and shuttle. Like, this is a question that you're probably gonna have to ask NASA directly. And you're at, like, you ask these questions each week, and I don't have any answers for you, so I don't answer them. Might younger people have any advantages as astronauts over older people? Yeah, I mean, health, right? So what you get for a younger person is that they're in better health, on average, in general, especially people who are trained to become astronauts. The advantages that older people have is skills. So when you look at, say, many astronauts, they have a pilot's license, they have an advanced degree, often multiple advanced degrees, and then they've gone through the astronaut corps program, and they're well-rounded human beings, and that requires a certain level of wisdom. And so you look at some of the like any astronaut, you talk to any astronaut and you get why they're an astronaut. They are interesting and they are well spoken, and you feel like you could work well with them in any endeavor and that you could count on them to save your life. And that's what you want. And so often young people, haven't developed all of those skills and training and wisdom and experience and expertise. And so there's this kind of sweet spot between where you have somebody who is young and healthy, but is also has the right experience and personality to be a great astronaut. And so it's sort of a balance. And, there have been astronauts that have been in their 60s. There have been astronauts that have been in their 20s, and it all seems to work out. And I don't think there's any, that you need to sort of push the scale either way, really. LDEK sock. Why do so many top scientists and physicists have a view that it could be alien in nature, and why is it such a perfect trajectory, which is one in millions? So there aren't a lot of top scientists and physicists. There is one well-known scientist who is holding the opinion that 3i Atlas is artificial in nature, and he only is giving it a 30 to 40% level, and that's Avi Loeb. And so, and the rest of the scientific community is mostly ignoring him, is the reality. That nobody else really shares that perspective. Nobody is ruling it out. Could it be an alien spacecraft? Absolutely, right? But what is your rationale to say that it is? And so right now it is doing things that are very comet-like. And although he has cherry-picked a bunch of interesting anomalies, like the direction of the orbit, the number of planets that's going past, you could further optimize each one of those things. Instead of it being 5 degrees off the plane of the ecliptic, wouldn't you want to make it exactly the plane of the ecliptic? Wouldn't you, instead of it going 0.3 AU away from Mars, wouldn't you want it to go within a few hundred kilometers of Mars instead of it being 1.7 AU from the Earth? Wouldn't you want it to go within a few hundred kilometers of the Earth to get really good pictures? All of these things that are coincidences, they could be better coincidences. They could be worse coincidences. There could be other coincidences. Why isn't it making a close flyby of Uranus? Why isn't it making a closer flyby of the sun? Why isn't it in a position to use the sun as a gravitational lens to make observations of other star systems, right? Like there's a whole bunch. You could go on. I could make a list of 1,000 interesting coincidences, and then that would be more interesting. That could be more interesting than what 3i Atlas happens to be doing. So, the trick is that if you want to make the claim that it is an alien spacecraft, you have to find evidence of it doing something that a comet can't do. And so far, nobody has found that. Nobody has found it doing a thing that a comet can't do. It's doing all the kinds of things that comets can do. They can move through space. They can have a coma of gas and dust. They can generate a tail. They can generate an anti-tail. They can have nickel and iron in their coma. They can have ratios of carbon dioxide to water. They can have ratios of carbon monoxide to water. They can rotate, right? They can have a shape. These are all things that comets can do. There's a whole bunch of things that comets can't do, like they can transmit radio waves along specific frequencies. They can't change their velocity dramatically to go into orbit around objects. They can't have a shape that is like a pyramid or a cube. They can't have a surface that is made of something that comets aren't made out of, like, glass or carbon fiber. So until the comet, the object, exhibits any property that is not possible by a comet, you have to just assume for now that it's a comet. Russ G11, can you explain Lagrange points? I did a series of videos about the Lagrange points, so I just recommend you check those out. I did 3 videos about the Lagrange points and why they're all useful and what the different missions are. So just do a search on my channel for Lagrange points and you'll get them. Annie Alexander, do you think the Triangulum Galaxy should get a new PR team? Andromeda keeps stealing all the limelight. Triangulum should get more love. Yeah, I mean, Triangulum is the other large galaxy that you can see with the unaided eye if you know where to look. It's hard, but you can see it. And it's not as big as Andromeda is, but it's definitely on a collision course with us. And that the 3 galaxies are going to merge. And I guess it's just that Andromeda is bigger and brighter and gets all of the attention. But Triangulum is right there. Maybe it just needs to try harder. Now, Triangulum has the largest star-forming region that we know of in the local group, bigger than anything we've ever seen in Andromeda. So maybe we should just focus our attention on that, this ridiculous star-forming region with tons of stars that are dozens of times the mass of the sun and popping off as supernovae. I don't know how you say your name. Let me translate this. King of Beasts. Why can't we send robots to Mars to build settlements under the ground before the first humans arrive to help them stay alive? There's no reason we can't. You know, it's probably a thing that will be done, which is that we will send robots first to make some kind of habitat that when the humans arrive, they're going to be able to move in. Like it just be confirmed that it's there and it's working and it's ready to go. The first ones will probably just be above ground because that's an inflatable habitat is easy to set up on the surface of Mars. But you can imagine a future one, you'll send a drill that'll bore out some kind of tunnel, a place where astronauts can go in and hide from the radiation. So it's infrastructure. We just need more infrastructure on Mars. Ed, what happens if someone commits a crime on the ISS? Is this under any laws? It's under the laws of the government that the person was a nation of when they committed their crime, and under the law of the nation that launched the International Space Station, and under international law. It would be very complicated for sure. Like you would have a very fascinating court case if somebody committed a crime on the ISS. KGS, other than RTGs, what technologies are currently available for overnighting at the lunar surface? The RTGs are really the only idea. Now, people are working on fission reactors that could work on the lunar surface. There's NASA's working on the kilopower reactor. I'm not sure, a lot of funding has been cut at NASA now for space reactors, so who knows? The other idea that I really like is using pipes to heat up regolith. So people have done the calculations for how you could run pipes of liquid under the ground and heat up regolith, kind of like they have sand batteries here on Earth. And so that would allow you to stay warm. You just have solar panels, you pump heat into the ground, and then you extract that heat during the lunar night, and it would work really well. Frosty Winnipeg, with Comet Halley on its way back, what current technology, when is the earliest we will see it? When is the next Comet Halley? It's going to be in the 90s, won't it? 2061? Is that right? Wow. Yeah, mid 2061. July. So I don't know how earlier we see Comet Halley. It'll be like a year or so before it will start to brighten up again. Man, I hope I'm alive for it. Wait a minute. Yeah, because I remember the last one we saw was in the 80s. So I was alive for the last Comet Halley. So hopefully I'll be around for the next Comet Halley. That'd be cool. Last question. Wandering Fool. Is there evidence that interstellar objects have added minerals to the Earth? There's no evidence, but it is inevitable that the occasional interstellar object has crashed into the Earth. Definitely interstellar dust has crashed into the Earth and added some material to the planet. So, but good luck figuring it out, because it would have been a violent impact, would have caused a crater. It would be hard to tell. All right, time to wrap it up. So thank you, everybody, for hanging out with us today. A huge thank you to Zapfan for helping put the questions into the YouTube. We fixed the problem that we had last week, but it's clearly still a little slow and cranky. So it was absolutely critical to have your help here. So huge shout out to Zapfan, and then the other moderators who showed up. I think Arjun is here as well. Thanks in advance to Chad and Anton, who are going to have to edit this nonsense and turn this into the question shows, as well as all of the overtime. Now, just want to remind you, if you're enjoying this experience, right? Like if you're enjoying watching this live, the second this is over, I'm going to set this live stream as unlisted. So it won't show up on our channel, but I will put a link on the Patreon, on the QA that we post to Patreon tomorrow for last week's episode. And so as long as you're subscribed to the Patreon for free, like it's totally free, you don't have to pay any money, you can just get all of our episodes, then you will get that notification every week when there's the full version of the live stream. And then we also chop it up and edit it and put in graphics and video and all that kind of stuff for all of it. So if you want that enhanced experience, definitely come and check out our Patreon. We've got some cool interviews coming out that should come out this week. The next big thing that's going to happen in an hour is Astronomy Cast. I'm going to be meeting up with Dr. Pamela Gay over on the Astronomy Cast channel. We're going to do an episode about comets behaving weirdly, maybe even asteroids behaving weirdly. So stay tuned for that. Go and check that out. All right. Thanks, everyone. And we will see all of you next week. And next week is going to be 5 p.m. Pacific time and not in the morning. So back to my evening. All right. Thanks, everyone. We'll see you later.